discussion on the OSI model of a system. It's a connection reference model. Okay, so if you remember, we have started describing the OSI. What is it, and what are the different layers inside it? Actually, it consists of 7 layers, as you know, starting from application and ending in the physical layer. So we have talked about application, presentation, session, transport layer, network, and now we're going to talk about data link and physical layer. We're also going to see how this reference model would relate to the de facto model, which is TCP/IP. Okay, so TCP/IP is considered de facto model, as you know, because the internet actually is based on it and it's working. So this OSI model was made after the implementation of the internet, so it's used only to describe the networks, protocols in a more formal way than the other models can do. Okay, so for the data link layer, it manages actually the physical transmission circuit in the physical layer and transform it into circuit that is free of transmission error. So what is performed here actually is what's performed is error detection and correction in addition to retransmission mechanism. In a way that why we are saying detection and correction, because actually we have to be very specific here. Some algorithms, there are some algorithms that use detection. They detect the error, such as correction. Some codes are based on this mechanism. They are Hamming codes, for example. They are used to detect, and sometimes will be used for correction. We mean by that actually for detection and correction, the detection will be by adding 1 bit, for example. For one technique like the Hamming code, you will add 1 bit to the end of the bucket, and then you can detect by the number of your ones in this bucket, if the ones are even or odd. Okay, so it means that if you assume that they will be odd all the time by setting the additional bit into a number that will make the result as odd, if it is changed, it became even, it means that one of the bits were actually not correct. Okay, so this would, for a scheme like this, actually it would detect at most one error. It cannot detect more than that. Okay, so this is only to give you like how it would be, how the error detection can work in this layer, the data link layer, and the correction or retransmission would be the process of correction. When there is a error in one of the buckets, then it is simply to retransmit it is simpler than the correction, because the correction could be based on many information, and it would take some time to regenerate the correct one. So at this layer, the data buckets are confirmed into frame. The frame is a data bucket in addition to the encapsulating information, including layer 2 addresses. So in this, let's have a look actually at For the data link layer, it will be divided into two sublayers, the logical link control sublayer and the media access control sublayer. The first one, which we call it LLC, it provides the interface between the media access method and network layer protocol. And another sublayer is called MAC, which is responsible for the connection to the physical media and physical address. Okay, so the MAC is responsible to give you the MAC address, which is called later on. This address actually would be generated from the manufacturer of your device, and it is processed in the data link layer. So to relate the information to your MAC address together in terms of frames. So actually a frame would be like this. It's not only a data, okay? It's a data plus CRC, which are correction codes, okay? And trailer, header. You will have also the destination and source address, okay? The MAC one and the other address. You will have the LLC header also. So these are the components. Actually, buckets, every bucket, whether it belongs to this layer or other layer, it should have the source destination in some way. So to know from where it is coming and from where it's going to. Okay. So the MAC address is permanently hard-coded on the NIC by the manufacturer. So the NIC is the actually it's a socket in which it is the network adapter. Okay, the network adapter attached to your system. It could be integrated in the motherboard sometimes. Sometimes it's in a separate card. Some people call it network card. Okay, so the scientific name for it would be network interface card, or NIC. It's a unique hexadecimal address for the Mac. It should be unique because it's given as an ID to every computer in the world. Okay, so if two computers will have the same MAC address, there will be a big problem. There, with the 6 pairs of hexadecimal digits, and is not duplicated anywhere. The first 6 digits are assigned to the NIC manufacturer, and the last 6 digits are unique value assigned by the manufacturer. Okay, so if you divide the MAC address by 2, the first 6 will describe the manufacturer, the ID of the manufacturer, and the other numbers will be assigned as a unique value to the device. Okay, so you see that here, for example, this chip, which is NIC, has some MAC address which is this way. It is written this way. So this is the part, the first part until A6, and the next part ends with 0C. Those numbers are hexadecimal. Okay, I hope you know. You probably know the difference between this numbering system. You had them maybe in other courses. So hexadecimal, this system uses numbers until A, B, C, okay, until 15, from 0 to 15. So it substitutes the 10, 11, 12 with A, B, C, okay? And you have also the layer under this is the physical layer, and the physical layer is the least, the last the last layer you have in the OSI model, which controls the rules for data transmission, including the electrical current, types of cable, the transmission speed. Okay, so it deals with the electricity, or no matter what kind of the connection is. It deals with the wired and wireless communication, including radio waves, including optical transmission, electricity electrical based. So it knows all of these cables and transmission types, and it can make them work together. Okay, like I sent, for example, 01 from a coaxial cable. It would be the same if I would send it with the optical one. Although in the layer behind, I mean the manufacturing layer, they work differently than each other. So it manages the way a device connects to the network media. All components are specific at the physical layer. Most of the standards here are defined by the IEEE, which is the Institute of Electrical and Electronic Engineering. It's very famous, okay? And you see here that these are the connectors. At this level, we see the connectors, the cable. So this is called RJ45, which is based on the telephone line. This is how the token ring look like. The jack in the BNC connector, which is for coaxial cable. This is similar to the dish satellite cable. You know, most of you have satellite in house. It has a cable, right, connecting the dish and the receiver device. It will be the same as this one, BNC connector. And this is how the fiber optic look like. You might find it in if you have a home broadband connection to the internet, you might have fiber optic connection. Okay, so it looks like this way, and the light goes into these fibers. So let's now move to other networking models. We talked about OSI, and now I will give you a complete example about how the data would travel through all of the layers. Okay, an example that will be a real example. So to see, to understand the responsibility of each layer. Okay. But before that, let's talk about the other models, such as the TCP/IP. It's the other model. We say this is a de facto model now because the internet is based on it. It originally was a DOD model, the Department of Defense in USA. So they have created this TCP/IP model. So it's actually organized in 4 layers. So you see, many things are put together. Like here, in this application in TCP/IP is different than the application of layer of OSI. If we compare, then the application of TCP/IP would include the application layer, presentation layer, session layer. All of these 3 layers will be in one layer, TCP/IP. For this host-to-host transport would include the transport layer on OSI, and the internet would include the network layer, and then the data link and physical layer will be on this network interface. Okay, so we can compare now. You see that this is a comparison between the two, the OSI and TCP/IP. You see three layers on the OSI will be considered as one layer, and then you go, because we have four. We have to map the 7 layer into only 4 layers at the TCP model. Okay, this is important diagram actually. You might be asked about please compare OSI and TCP. So you can draw this only, and it's a comparison. Okay, and this will be the TCP. Actually, it will have the same functions of OSI, but with this new organization. So the application or the process layer will handle the way application at two source and destination devices process information as it's sent and received. The host-to-host or the transport layer will manage the flow of data between the two devices and the type of transmission, as it either connection-oriented or connectionless. The internet layer will, or the network layer, will provide a hierarchical addressing scheme used to identify devices on the network, so that every device on the internet has a unique address. Okay, and last thing, the network interface, which will be equivalent to the last layers, like the data link. It manages the transmission of data with the network and functioning like OSI data link. That's it actually. For the internet model, the internet model dominates current hardware and software, and is similar to OSI model but collapses the top 3 OSI layers into one. Unlike TCP/IP, the internet model does not include a physical layer. So let's have a look at the internet model. So you see that here is, let's compare with this TCP/IP. You see TCP/IP is 4, the internet model will be 5 layers. Okay, so this will be actually the same. The internet model is very similar to TCP/IP. The only difference is that one has no the physical layer. So the group of layers, sometimes we might see a group of layers. We might organize in group of layers. So layers are seen as closely coupled groups. Do you hear me, guys? I think my sound is reaching. Yeah, okay, thanks. Okay, so the groups of layer will be another organization for our model. We can have a model of a group of layer in which when designing a network, we might think of a network design in 3 groups: hardware layers, inter-network layers, and application layer. Okay, so these can be the many types of layers according by grouping them. And here we can see the differences between all of these. Like we had the OSI model, the TCP and internet model. Actually, they are nearly the same. Okay, they are nearly the same because actually the internet also is based on TCP/IP. The group of layers, and this will be the types of protocols that can be used in each of the layers. Okay, actually we have finished now our chapter, the rest of the chapter from the face-to-face lecture. Let's go through a summary, and then I will give you an example of how it will work. For example, when you uh, send data when it goes to the through the application layer, then the presentation layer. What will happen exactly? Okay. So, as a summary, standards are necessary to make sure that the devices and applications from different vendors can work together. We should have standards always. Standards are very necessary in the internet and networking in general, because whenever you have something of data communication, you need to agree on how you can communicate. So they can be either formal or de facto. The official governing bodies develop formal standards, and those de facto standards actually come from the marketplace, okay, based on the success. So whenever there is a model that has a great success uh, on the market, it would be a de facto standard. The OSI model is most commonly used to describe network hardware and software. The TCP/IP model has only 4 layers, while the Internet has 5 layers. Okay, and the Internet model is currently the dominant model in the hardware and software. The, the primary difference between TCP/IP and the Internet model is that the Internet model includes the physical layer defined in the OSI model. Okay, so what are you required now to know about this chapter? You have to know all of the 7 layers, definition of each of them, some of the terms relating to these layers, and also to know how you can compare between OSI, TCP/IP, and Internet model. Okay, what is the difference between all of them? So these were the learning objectives. Now let me give you an example for example, let me have, for example, communication between two people or two applications to see how actually the message will be delivered. So, for example, I decided that I want to connect a web server at some IP, like this IP. Okay, so which layer am now? Where am I now? For example, this layer. No, I'm talking now like I am a user. Okay, I am a user. Have any? Okay, just to describe the idea. So I am user sitting on a computer. Okay, this is my computer. Which layer I'm currently using? I want to send the message. No, not physical, because we haven't reached the physical. Yeah, the transport layer. Right, right, Khalid. Because I'm having application now. I want to set to this address I have sent to you. Okay. So what is happening actually? Uh, uh, I will put this address into my browser, right? So I have my browser. I want to HTTP, for example, this one number. This is my IP address. I inserted and pressed OK. That I want to make communication. Now this will be, we are at level 7. Okay. For level 6, it would examine if uh, uh, actually we are at the application layer. Okay. We are at the application layer now. Who told me not transportation? We are at the application because after the application we go to the presentation, right? So when you send this data might be encrypted. That I'm sending my request to this page might be encrypted, such as HTTPS, for example. HTTPS uses encryption. So if there is encryption, compression to the data, anything could be done at the session or the presentation first. This processing could be done at the presentation. It is about the format of the data. It will be formatted in encryption or in plain text. If it is in plain text, then it's okay. It will go as it is. So and then at level 5, which is the session. In the session, my request will be sent via a call to an application program interface to issue command necessary to contact the server at that address. Okay? And after that, when we go to the layer 4 or the transport layer, then the TCP, which is a protocol at that layer, will be used to create segment to be sent to IP address, the specified IP address. Okay, so now we are at the transport layer. These will be the phases of the transmission. We haven't exited the station yet. We are still in the station. We have passed through application, presentation, session, and then the transmission would create the segment to be sent to the IP address. Now it is sent. Okay, we go through layer 3, which is network. So the computer creates an IP datagram. It's called datagram. It encapsulates TCP bucket created in the previous in the transmission. It then sends the bucket to the IP, but it could discover that it's not on its local network. So you see, this is now the process of routing is working at level 3 at the network layer, because this guy might be I am here in, for example, in university. We have like a certain range of IP addresses, but the guy I'm sending the request to him is like on a server in USA. So the computer might discover that it's not the guy I'm communicating to him is not on my local network. So it realizes it needs to send the message to its designated routing device at the IP, and then it has the bucket to the driver of the Ethernet card. After that, the Ethernet card, or it will be the NIC card, forms a frame containing the IP datagram and prepares it to be sent over the network. Okay, so it packages the message and put the address. The address actually will be changed according to the new route. We are now at the data link layer. Okay, so the frame is sent now over twisted pair cable or over fiber optic cable that connects the local area network. It deals with the collisions with this electrical errors could be happening here, and then the data is there. Okay, now we are at the physical layer. Now the Ethernet card at the machine with the IP address receives the frame, which is the uh, it's in the middle, okay, because we have sent the packet. Uh,
Recording in progress.
Resend the datagrams again. So again, we are going to another router and go through go through network layer, which will receive, and then layer 2, and then layer 1. Okay, and at the reception, the IP headers are removed from the datagram. The TCP will be handed up to the upper level, which is transport. Now it is inside the machine. The TCP removes its head and hits the data up to the drivers on the destination machine. At the session layer, the request is sent to the web server software for processing. At the presentation layer, again, if it was encrypted or something like HTTPS, then the encryption will be erased and put in plain text again. And finally, at the last layer, 7th layer, on the application layer, the web server will receive and process the request. Okay. So, so you see this long journey we were talking about. Actually, you see, it's not that
recording in progress
for your request at the application layer to go, and it will go and go up until it reaches. So it moves through the layers. Each message or a kind of communication between two parties in the network. This was all for this week, inshallah. We meet again next week with a new topic in chapter 3, inshallah. Okay, so please don't leave until I take your attendance. Okay, thank you.
Recording stopped.
See you next week, inshallah. Goodbye.